Hi everybody, today our lesson is on ratios and units of measurement. As a reminder, you do not need to write down every single thing that I talk about in this video, but be sure to jot down important information and at least one example of each type of problem that we cover. Remember also that you can utilize the pause button to jot down important information or notes before moving on, the rewind button to view information again, and the fast forward button if you think you got it. Just be careful that you're not fast forwarding too much and you miss out on something important. So with today's lesson on ratios and units of measurement, it's really a review of equivalent ratios. We're just talking more about measurement. So what we mean by measurement is just any kind of unit that you use to measure something. You could use measurement to measure the length of something, like in centimeters or inches or feet, miles, kilometers. You can use measurement to measure how tall something is. You can measure the volume of liquid, like with cups and gallons and pints. There's plenty of different measurements that we use. And we actually use different measurements depending on where we are in the world, and we'll talk more about that later. But you should have definitely touched upon units of measurement in science, because you definitely measure objects in science a lot. So in order to be successful in this lesson, we need to review equivalent ratios. So let me scroll down to when we talked about that. We talked about equivalent ratios when we were looking at these apples to pears. The original ratio was 6 apples to every 3 pears. That was our original ratio. We talked about how we could write that ratio 3 different ways, with a colon, with the words to, and also in fraction form. Equivalent ratios are basically expressing the same relationship, but we're just magnifying it through multiplication, or we're reducing it through division, but it's the same relationship. So if I say there's 6 apples to every 3 pears, I could double everybody and then double that, the way that we're expressing that ratio. It's the same ratio, it's just everybody is being doubled. So now it becomes 6 times 2 and 3 times 2, which gives us 12 to 6. You still have 6 to 3. There's still twice as many apples here compared to pears, right? Because 6 divided by 2 is 3 and 12 divided by 2 is 6. The only difference now is there's twice as many apples and twice as many pears. Same thing can happen if you divide. So instead of 6 to 3, you're getting 2 to 1. So it's still twice as many apples as pears. We're just expressing it a little bit differently, but it's the same relationship. So that's what you need to remember for converting units of measure. We're not changing anything. We're just saying it a little differently, okay? So let's take a look at this example. This problem asks you to complete the ratio table to convert the units of measurement from centimeters to inches, or backwards from inches to centimeters. So this is what we mean by, it's really the same thing, we're just writing it differently. So basically in the United States, we use measurements like inches. In a lot of other countries, like in England, or actually other countries that have had influence from England, they follow the metric system, where they use centimeters and meters and decimeters and kilometers and all that. So it's the metric system. That's why you can see meters, metric. It's actually the older way of measuring things, and it's neater. So a lot of the conversions are by tens, hundreds, thousands, and just multiples of 10. So this one is the metric. So it's multiples of 10. And the measurement system in the US is actually a little bit messier. So we don't go by tens, hundreds, thousands. We say like there's 12 inches in 1 foot. Or we say there's, 2 pints or 4 pints in a quart or something like that. So it's just kind of like random numbers because we developed our own system, basically. So basically, if somebody in the U.S. had something measured in inches, they would need to change their measurement from inches to centimeters in order to communicate, right? One of our core values, they need to communicate in the same language, same measurement language as someone else in a different country. And vice versa, if somebody in England is using centimeters, they would have to convert their measurement to inches so that we understand what they're talking about. You're probably thinking, why do we have such different systems? It seems like a waste of time. I totally agree with you, but until we're the people who can make those changes, we kind of have to do this. So math is very useful in a lot of communication between scientists and engineers and just like normal people who measure things. So basically that's where we use that concept. So let's take a look at this problem. If I need to convert centimeters to inches or inches to centimeters, I need to use the same concept as I've been using with equivalent ratios. So I need to look for relationships. I need to think to myself, okay, what is the relationship between centimeters and inches? Like, how do I change centimeters to inches? One thing you can think about is you can think about that multiplicative relationship. What does 1 have to multiply by to get to 2.54 or 2 54/100ths? So pause the video and think to yourself, what does 1 have to multiply by to get to the other side of 2.54? If you thought to yourself 2.54, you are correct, because anything times 1 is that number itself. So we could do that in our calculator to try it out. Okay, so we're trying out 1 times 2.54. That should get us to the other side of 2.54. Yes, it does, because anything times 1 is itself. So that's our magic number there, okay? That's how we get from inches to centimeters. So on the way backwards, we got to think, well, what's this relationship now? Going in the backwards motion, in reverse motion. Pause the video and think to yourself what that relationship would be. If you said same number but different math operation, you're correct. They should have the same relationship, the 2.54, but now we're going backwards. So what is the opposite of multiplying? That would be dividing. Same relationship, 2.54. So now we're going to take 5.08 or 5 8/100ths, and we're going to divide by 2.54, 2 54/100ths to get that answer. So we have 5.08 divide, because it's opposite, by 2.54, and we get 2. So that looks like it was just twice the amount. Twice the amount. So I'm thinking to myself, if that's just twice, I'm wondering if 2.54 times 2 would give us 5.08, just like how 1 times 2 would give me 2. So let's try that out. So there's a lot of different patterns that you can find because they are equivalent, basically like equivalent ratios. 2.54 times 2 is 5.08. So we basically took twice the amount of centimeters to get 5.08, which would mean it's twice the amount of inches as well. So in the US, we would say 2 inches. And in the UK, they would say 5.08 centimeters. We're basically saying the same thing. They are equal to each other, okay? So pause the video and see if you can figure out this last blank. There's 2 different ways you can get there. All right, one way that you could get there is that you could have seen that 1 up here times 10 would get us to the 10 inches. So that would mean the 2.54 would also multiply by 10 to get us to the amount of centimeters, because they are equivalent ratios. Equivalent ratios are very important. That's actually why it's usually the first unit in class. 25.4, because we're just moving it over 1 decimal place. So 25.4. The other method would be to use our multiplicative or divisive patterns. So we are going from inches to centimeters. If I were going from inches to centimeters, I gotta follow this relationship up here, because originally I multiplied the inches by 2.54 to get to the centimeters. So I'm going to do the same thing over here. And we actually did that same math, 10 times 2.54 over here, 10 times 2.54. So both of them were the same type of math to get to the answer. So that should be our correct answers. Okay? So it's just equivalent ratios. It just looks a little bit different because now we've added in those measurements, centimeters, and inches, and kilometers, and all that good stuff. But they, again, the 2 different countries are still measuring the same piece of paper or the same container, so they still need to have equivalent ratios. Let's try one more problem. Yuki bought a pound of confetti for $12. What is the price in dollars per ounce of confetti? Remember that there are 16 ounces in 1 pound, and Yuki bought 1 pound for $12. They want to know what's the price in dollars per ounce now. So go ahead and pause the video and see if you can solve it on your own. Yuki has bought a pound of confetti for $12. We need to figure out how much it costs per ounce of confetti. So I'm going to write my information down. I have $12 per 1 pound. I like to write out the word pound because I feel like the LB for pounds looks like a 16 if I wrote it really quickly. So I like to just write out pounds. So it's $12 per 1 pound. It's important to note that this right here is a rate. They're telling us how much something costs per 1 unit. That's a unit rate right there. And what they ask us to find is also a unit rate. They want to know how much it's in dollars per ounce. So they want our answer to be a unit rate. How much money per 1 ounce? They told us that there's 16 ounces in 1 pound. So we need to change this 1 pound into ounces. There's 1 pound. So how many ounces is it? 16. Okay? If it was, let's say, $12 for 2 pounds, and there was 16 ounces in 1 pound, that would mean that there's 2 of those 16s, because there's 16 ounces in 1 pound, and you have 2 pounds. So it would be 2 times 16. Okay, so then that would give you 32 ounces. So right now it's 1 pound. 1 pound has 16 ounces. So this is the same as saying it's $12 for 16 ounces. You draw that line through it all so it looks like a 2. Sometimes letters can look like numbers. So now that it's $12 for every 16 ounces, they want to know how much is it per 1 ounce. So what do we need to do to find that unit rate? You need to think to yourself, what's the math operation that you perform to find unit rate? Is it adding, subtracting, multiplying, or dividing? You should have said in your head that it is dividing. So we're taking the $12 and we're dividing it by the 16 ounces so that we will get how much it is per 1 ounce. So in my calculator, I am dividing 12 by 16. And that's 0.75. When we talk about money and it's 0.75, we're really talking about cents because it doesn't make up a whole dollar. So this is 75 hundredths of a dollar per ounce, or you can say 75 cents per ounce. But here they have the dollar sign, so you want to keep it in the decimal form. So it's 75 cents per ounce. You don't need to write the per ounce because that they just want the dollars, the dollar amount. Okay, so that is another question on converting units of measure. Let's try another one. Ooh, this one looks interesting. It's got a double number line. Double number lines are very similar to your tape diagrams that we showed you before. Tape diagrams, if you remembered, we had something being calculated on one side and something else being calculated on the other side. And then we had bars dividing it in between. Okay, so you're basically tracking two different aspects of the problem. So double number lines are the same thing. You just see two different lines and they're tracking the same thing. However, these lines match up to each other. So they're kind of just like tape diagrams without the box in between it. This one says the double number lines show the ratio of feet to miles. How many feet are in 3 miles? Go ahead and pause the video and see if you can figure this out. Alright, so we already lined up these double number lines and we saw that 0 feet is equivalent to 0 miles. If I say 0 feet in the US, someone in the UK knows that's the same as 0 miles. Nothing means nothing in every country. Now when I say 10,560 feet in the US, that is just equivalent to 2 miles in the UK. They just use different measurements. It's just like if someone used paper clips to measure something and another person used buttons. It's the same thing they're measuring. You're just going to have probably a lot more buttons if they're smaller, okay? So like if I had buttons that are this big measuring something versus a paper clip that's this big, it's going to be, let's say, 6 buttons, but 2 paper clips, okay? Same length, still measuring the same length, but they're using different units. So they're going to have different numbers, right? Because they're different sizes. My buttons, 3 of them equal to 1 paper clip. So I'm going to have twice as many buttons as my paper clips. Same thing with the feet and the miles, okay? So we are trying to figure out now how many feet are in 3 miles. Here's 0, here's 1 mile, here's 2 miles, and here's 3 miles. So we need to figure out this number up here. Wow, I have 1, 2, 3 numbers and 1 box. That should look very, very familiar to you. 3 numbers, 1 box. That looks just like our equivalent ratios. So we have the, let's say, miles over here, and we have the feet over here. We're making our labels. I have 2 miles for every 10,560 feet. And then I have 3 miles for who knows how many feet. We need to figure out the relationship, okay? I can figure out the multiplicative relationship to figure out this box over here. Or I can figure out this multiplicative relationship over there. Looks like this one might be easier. So what does 2 have to multiply by to get to 10,560? Well, if I don't know, I'm going to take that bigger number, I'm going to divide. 10,560 divided by 2, and I get 5,280. So basically 2 has to multiply by 5,280 in order to get to the other side. Oops. Times 5,280. So that's the amount of feet in a mile, actually. That's a very famous number. There's 5,280 feet in a mile. So if you can remember that, that'll make your life even easier next time you'll remember that. So to get from 3 miles to the unknown amount of feet, we would just take the 3 and multiply by 5,280. And that's 15,840. 15,840. That should be our answer. So it's just a lot of equivalent ratios when we're talking about units of measure. Because again, we're all measuring the same thing, just using a different language. Okay, so let me know if you have questions as you work on this exercise, and just be careful that you're not getting confused by the units of measure. Know that you're doing the same thing as you've done before. It's just with units of measure. And if you don't have any questions, I will see you in class.